Hello again. Today I will explain a little bit about Moveit. Moveit is a package in ROS that enables you to use in an easy way manipulators. In this case, we are using UR5 universal robot manipulator. There are three types of manipulator of universal robot, at least that's what I saw on the web. UR3, UR5, and UR10. Also, we are using a RobotIQ Gripper to enable the robot to grip something. But right now, I will only explain Moveit and an issue about UR5 or the UR models or any other robot that has this issue. So first, let's make a Moveit package. In example, say, let's say you want to configure a package to use Moveit and the RViz planning interface just to test if the arm moves in simulation, I mean in visualization only, and then in Gazebo. So the actions that you plan in Moveit are executed in Gazebo. So suppose that we want to configure our robotic arm. In that case, we have to have uh, URDF for our model of our robot. In that case, I made that one with the UR5 and RobotIQ. Let's say it's placed. No, it's not displayed. Let's try again. Okay, here you see it's a UR5 and a RobotIQ arm. So pretty simple, just to test the Moveit framework. So back to the when you have this URDF or sacro file from your robot, in this case a manipulator, and we want to launch Moveit to configure it. Let's launch Moveit to see it. Let's launch Moveit, setup assistant, setup assistant.launch. Okay, here we have our Moveit setup assistant. We want to create a new robot arm configuration because that's what the first thing that we want. So in my case, I have in a workspace named UR workspace. Let's say we want to launch a configuration file here. We have to get the SRDF format or the URDF format of a robot. In my case, is here on URDF, this one. Let's open, load the files, and here you have or the same robotic arm that we visualized on Visual Studio Code, and also the gripper. So you continue with the self-collision metrics that are it ensures a verification wave of 6 positions of the robot that not collide itself. So next, you enable a virtual join. Let's say virtual join. Also, we will link the base link with the world and save it. Planning groups. Let's add 2 planning groups. Let's say the arm, a kinematic solver. Let's say this one, and let's use RT connect. Let's say that. Next thing is to enable the joins. So the joins of the UR5 are these ones. This. We're done. Add the joins. Okay. Now add the gripper. Kinematic solver. No, we don't need kinematic solver for the gripper. Okay. And add the joins again. Let's say we add the joins. Gripper finger 1 joint and gripper finger 2 joint are revolute joints. Let's see. Yes. variable JS. We can add a lot of more configuration if we want. Let's keep it simple. But suppose let's say that we want to post our home and the post Gripper home to the Gripper. You can test if you want. You can move the and test that the Gripper is moving, all the joints are moving. In case of the arm, let's say we only want that. And effectors, we have an effector to the Gripper. An effector group Gripper button usually pays as the arm is the whistling. Let's say we want to vinculate it to the arm. Okay. Passive joints. We also have passive joints on the Gripper. We have this one, this one, this one, and this one. Those are the passive joints. Okay. Passive joints, the ROS control, automatically add the ROS controls. Okay, that's for controlling the robotic arm in Gazebo or also in real life. Generate URDF if you want to copy and paste to use this URDF with the control transmissions and so on, but everything is okay. And let's say we want a point cloud instead of a depth map to enable the octomap. Say right here. Okay. Finally, where we want to build our configuration files. UR5 RobotIQ Moveit config. Okay, create, open, and generate the package. Okay, now we exit setup fixed time, and that's okay. Let's say we want to have some sources and we want to make the package. We have make the package and so on. So in the end, you have this configuration and a lot of launch files. But the most important one are the demo.launch and the demo_gazebo.launch. So let's launch those launch files. Okay. Let's wait a little bit to finish the compilation. Will take a little bit. My PC is not a lot faster than yours. And we source the package. Okay, now the moment of truth. Let's launch this one from here, from UR5 sample movie. Sorry, this one. This one. The launch file for here, those launch files. So we start with ROS launch, sync, UR5 RobotIQ, IQ Moveit config, demo.launch. Okay, it says that you can plan now. And here we have our arm. Let's move a little bit. Make a bigger size for manipulation of our arm. Since of the rod. Scene, no, it's not on scene. It's on planning request, I think. Yes, here. 0.2. Okay. Here we have our marker. We can move the arm. Let's say we can move it here. And you start planning. Oh, everything's go fine. Now we know that our planning goes well on RViz. So we will stop this one. The next thing that you want to do is to make planning in RViz and also execution or on real life or in Gazebo, in this case Gazebo. So we will launch this one, the Gazebo launch. Okay, let's see the error messages. So, okay, we'll launch everything, and here it comes. It's a warning. It's about the withdrawn join. Ignore it. It says controller's partner has died. Okay, there is a problem with the controller, so the controllers are responsible to move the arm in Gazebo or in real life. So it's obvious that probably the arm will not move. Could not find the planner configuration known the parameter server. So there are no planners, and also there are no controllers associated to the arm. This is normal. If Gazebo does not find the P gains, D gains, and I gains of your controller, it will assign the default one. It's a warning about the correct syntaxes, doesn't matter. And also the same error of the controller, doesn't matter. The odd parts are here. There are no controllers and no action client connected, obviously. So let's say that we want to plan. Let's say that we want to plan. Okay, here's our position of our arm. Here's Gazebo. We want to plan. Let's plan. Planning. Okay, it's not a safe move for the arm. Let's do another random. No, another random. Something more simple. Probably this one here. Okay, it's not a valid one. Okay, it doesn't matter. Let's say that we want to move the arm because that's what we want. So when you do execute, it fails. It says there are no controllers enabled or associated to the robotic arm instead. So I made some changes according to that for the launch files. I actually modified the configuration file, I think. Where is ROS controllers? Because the problem is with the controllers. I made some modification here and some modifications on the launch file of the controllers, obviously. But this change doesn't work. I will show you at least what I did, and then I will propose you the solution because it's working for the Panda arm. So the hint and the solution here is for the Panda arm. The Panda arm has the necessary files for you to do the startup and, let's say, commissioning of the arm and try to move it on Gazebo or also on RViz. So let's see what we did or what I did. Okay, let's say. Okay, this is a course that I'm doing about ROS, and I have an issue here about that, but it's closed. This one, control is not loading. So this is the step what we have. What I implemented and it doesn't work. First, in this file, you have to enable it as a list because, as you saw, Moveit doesn't put this dash, and when you're trying to load the controller, it expects to be a list. So for making a list of joins, you have to put a dash here. So let's say, let's see. I want to say here. You see where is the joins here. It's not in a list. So it's the first thing that when you try to launch your controller, you will note there's an error on that. So okay. Another thing that you need to note is that there is a controller list, and inside the controller list are those controllers. But in my case, what I tested, because I'm explaining here something that makes me logic and launch and everything is fine, but it doesn't work. In the end, I will explain what worked on the next video. I am explaining the path of how to configure this thing, or at least I thought that you must configure for other arms. Probably it will work, and I will explain you that here. Okay, let's see. As you see, where is there are controller lists, and inside the controller list are the controllers. This is the default configuration. So for load the controllers, the first thing that you need to do is to disable that and put on the side those controllers. Okay, let's do that. Let's do that. Okay. So I know that it's not the default way, but it's the way that at least I tried and executed successfully the launch of or the loading of the controllers. And next thing, you will need to modify the ROS controllers and try to spawn the joystick controller, the ARM controller, the Gripper controller, and other controllers that you have. Okay, let's see. ROS controllers. So here, as you see, it is loading on the parameters server. All those controllers are here. Okay. And we want to load another controllers. Okay, so I told you that we want to get this controller and launch it. The joystick controller, the ARM controller, and the Gripper controller. Because the ARM and the Gripper are in the same action namespace, I think. On the action namespace, on other thing is it does not launch in the same controller, so we want to configure another controller for the Gripper. Icon controller. Let's put another name to one controller and the other. The next thing that we need to do is, okay, if you launch it on the controller side, you have to also remap. If you have another joystick name, you have to rename your joysticks from robot joysticks to joysticks. So there's a way to do remapping. Also, you can use the remap tag to remap your joysticks. So when you launch it, you have this error, and it's related to the position controller. So if you do a ROS service card to the controller manager and list all the controller types, you get all the controller types. So we will use position controllers, join position controllers, let's say. Position controller, position controllers. Okay. You can use anyone, anyone of the list of the states of the controllers. I mean the list of the controllers. So position controllers, okay. Also, if we want to stop another controller because we're trying to use only two controllers, one for the Gripper. The error is not an error if you have another group and you launch the Gazebo launch and the controllers loads. If you do not stop one of the controllers, you will see error of, not an error, a warning about the TF that is reproduced redundantly. So workaround is to add an argument on stop the controller. So we're fine. We expect when we launch Gazebo, everything's going fine. Let's see. We'll stop here. Okay, let's launch again the launch file of demo Gazebo. Okay, let's see, error cannot load the control because the type position controllers join position controllers does not exist. User service account. Okay, I named badly the controller name, so let's see what another type of position. Let's use this one, position controllers join trajectory controller. Position controllers join trajectory controller, I think. Join trajectory or join trajectories? Join trajectory controller. I think that the problem was that it's join position controller, not join position controllers. But let's use this one, trajectory controller. Forbidden trajectory does not exist. Okay, again, I badly put. Okay, I put it on the action. No, it's fine. Everything must work, let's say, correctly now. Have another error. The joins parameter is not okay. What I explain? Where is the here? Okay, now we will launch again. So here you have it. Just only the error gains and a warning here. There's an error of no controller list because we don't have a controller list. Could not find the planner configuration to known. The parameter server is something odd about the name of the planner, but it doesn't matter. I don't know why, because we specify the planner. But let's say we want to plan some random valid configuration or goal state for your robotic arm. Let's say here we want to plan. We plan OK on RViz. And now we are going to execute something on Gazebo. Let's say we want to execute. And it say fail. When we saw again here, not identifies any set of controllers, but let's say we want to see if there are controllers loaded. So I think it's raw service count controller manager. List controller types. No, controller list. controller manager. List controller manager, list controllers. Okay. So there's the other thing you have here: the joystick controller that is running, the arm controller that is running, and the gripper controller that is running. So we don't know why, but it's not working. So that's the thing I tested. And if you try something on Gazebo, on some robotic arms, it will fail. Also, there's um, an open issue on the Moveit ROS planning Git about those things. Always they refer to the Panda arm. So, I know the Panda arm is working, but why it's not working my arm? In this case, the UR5 and the RobotIQ. I want to make it. I know that Moveit is road agnostic, so I made a lot of things that was the most close to the thing that it worked. Probably it will work on another robotic arm because I think problem with the UR5, or probably not, or probably only the controller spawner that is making odd things. But in the next video, I will explain what to do to move your robotic arm if you have all those issues, and also in Gazebo. So, I mean, planning RViz and executing Gazebo. So that's all. Thanks, and keep an eye on the next video.